Bismillahirrahmanirrahim. Previously, I suggested to you that if you're given any 2 points, those are some ordered pairs over here. If you're given any 2 points over here, here's 1 point, here's another point, and if you wanted to find the equation of the line that goes through those 2 points, either in the slope-intercept form or the point-slope form or the standard form, ax plus by equals c, the methodology, the protocol, or the way going about that was as follows. Either you can find the equation first in the slope-intercept form or the point-slope form, and then you would have to convert that into the standard form if you needed to. And the first step in the process in both of these scenarios was the same. First, you had to find the slope. So you had to find m over here, and here again in the same process you had to find the slope. So you can't get away without trying to find the slope, because you can't really write the equation of line unless you know the slope. The second steps were slightly different. Here in this particular form, the first form, once you find the slope, the next step was to find the y-intercept over here. So you have to find the slope, and then here you find the y-intercepts, right? So the way you do that is, once you find the slope, you write your working equation and take one of these points and substitute that in place of x and y, and then solve for b. In this case, your work was really done, and you just kind of enjoy it because you can just substitute one of the points because this is the point-slope form. So once you find the slope, you take either one of these points and then substitute that in place of x1 and y1, and you are done. So that's how you go about finding equation of a line if you were given 2 points. Thereafter, if you wanted to find the equation in standard form, you take either one of these forms, and then you can convert it or manipulate the equation into the standard form like this, where x and y are on one side and the constant term is on the other side. This particular diagram that I have drawn over here is imperative for you to and it's very, very important that you understand this, because it's kind of like the bedrock of much of algebraic processes that we do over here. So you have to really, really know this. Now, if you wanted to find equations of lines that are parallel to these lines and perpendicular to these lines, you have to first also have mastery of this particular concept. Now assume for a second that I'm given this line, this white line over here, and I'm asking that you, okay, I want the equation of a line, not this one, this white line, but a different line that is parallel to this first white line, but it goes through this point over here like this, the y-intercept here being like 2, okay? So I want an equation of a line that is parallel to this line over here. That is, these two lines are parallel, but it goes to this particular point, and we can label that point as x is 0, y is 2, like that. Now, how do I go about doing this? The basic idea here is that anytime you want to find equation of any line, the thought process is kind of like this. You try to find the equation of the line either in the slope-intercept form or the point-slope form, and if you want to convert that into standard form, then you convert it into standard form. So the thinking is always, if you want to find the equation of a line, you don't try to find it in the standard form. You try to find it either in the slope-intercept form or the point-slope form, and then you can convert it into standard form if you needed to. So if anytime you're asked, for example, therefore, to find equation of a line, okay, to find equation of a line, you want to try to get it in the slope-intercept form or the point-slope form. Okay, that's what you want to do. And in order to do that, then you know how to do it. There's only 2 steps, okay, and they're not that difficult to remember. The first step is you have to have the slope. So if you want to find the equation of this line over here, then you have to know what its slope is. Okay, so somehow you're going to have to figure out the slope. And secondly, either you find the y-intercept, or if you know a point, you can just plug the point in and you can write the equation of the line. Okay, so that's the rationale behind finding equations of lines that are parallel and perpendicular to lines that are given. So first of all, we're given this white line. Let's see if we can write the equation of the white line. Okay, so, well, do we know the slope of the white line? Okay, so let's see. Even here, I try to think of this in terms of the slope-intercept or the point-slope form. Well, do I know the slope? Well, I don't know, but I can find out. I can try to guesstimate it. You know what I'm saying? So let's see. You can pick any 2 points, and I made it so that these actually intercept right here. They're meant to intercept. I should have given those 2 points. So here I can just box out the slope. Slope is change in y over change in x, right? So, and it's a positive slope, so I go up 1 and over 2. So the slope is 1/2. There we go. I'm halfway there. I found the slope. And then, do I know a point? Do I know the y-intercept for one thing? Oh, yes, I do. The y-intercept is 1 over here, right? So it's kind of, this one is easy. Obviously, I made it kind of easy for you. So the y-intercept is 1. Or if you wanted to do it this way, do we know a point that's on the line? Well, you can say this point is on the line, right? So that point is x is 0, y is 1. So either way, so we have sufficient information here to write the equation of this line. So the equation of this line was y equals to mx, slope is 1/2, and plus b. B is 1. The slope is the y-intercept is 1. So we got that. So now we know the slope of this particular. Now, if you wanted to do it in point slope and use this point, it would be the same thing. So you can say y minus the y1, that's over here, equals to slope times x minus x1. And that ends up being the same thing, isn't it? Because if this is y minus 1, if you x minus 0 is just x the last time I saw it, that's that. And then you can put the 1 over here and you get the same equation. Okay, now at last. So here we first found the equation of this particular white line. Okay, now our goal was, however, to find the equation of this light green line over here. Okay, to do that, okay, I have to do this. I have to find the slope and find the y-intercept, or find the slope, or find the point that's on the line. Okay, so step 1. Do I know the slope of this green line over here? Well, if they are parallel, if the lines are parallel, of course, then the slope would have to be the same. The slope of the line that I'm looking for, therefore, is 1/2. Okay, that's easy peasy. So since I know the slope, and then I can write my working equation, or what I know about the lines is y equals 1/2 x plus b. All I need now is to find the y-intercept. Well, do I know the y-intercept of this green line over here? Do I? Well, yes, I do, don't I? It's right there. I'm given that. That's the piece of information that I was given. So the y-intercept was 0, 2. So the y-intercept was 2. And that's just pretty easy. So just from looking at the graph or what's given information, the y-intercept was 2. So can I write the equation line? Of course I can. So this is y equals to 1/2 x plus b. B was 2, and there it is. And that's the equation of this particular line over here. If I wanted to, I can just write it over here. Y is equal to 1/2 x plus b plus 2. Now, if you recognize any line that's parallel to this original white line is going to have the same slope like this. So there's the only difference will be their y-intercept is going to be different. So there are an infinite number of parallel lines, right? And the only difference between each of them would be what the y-intercept is, correct? So, and that's how you would go about finding a line that's parallel to this line. Now, let's say if I told you I want an equation of this line that is parallel to the original white line, but it goes through this point right here. Let's call that, let's make that more creatively. Let's make that this point right here. So that point is x is 3, y is -2. So what I'm saying now is I want an equation of a line that's parallel to this one, but it goes to this point like this. I did that, right? So we don't know what the y-intercept is, okay? We don't know. So it's going to be somewhere over here, it looks like, but we don't know what the y-intercept is. So how do I go about doing that? Well, as I said, the way you find the equation of any two lines to think about this particular diagram, the way you do is either you find it in slope-intercept form or the point-slope form. Okay, then there are 2 steps to that. Okay, step 1. Okay, so let's see. For this particular line, step 1 is, do I know the slope? Well, the slope is going to be the same as the white line, and that's going to be 1/2. I know that slope. And then you say, well, do I know the y-intercept? Well, you can say, so for y is equal to mx, that's slope, plus b. I don't know the y-intercept, right? But we say, well, how do I find the y-intercept? Well, here you can find the y-intercept by taking this point and then substituting that in place of x and y. So that 3 goes in place of x, and -2 goes in place of y, and you can solve for the line, right? So you can do that, and that's perfectly legitimate to do. Or if alternatively, if you wanted to go find it in this form, in the slope-intercept form, you could just say, well, I found the slope, I might just rather enjoy it because you're actually given a point here. It's on the line, and you'd be done. So all you do is you substitute this point in this equation using that slope that you just found, and you would be done. So for example, so it'd be y minus, be careful, y minus -2. So y minus -2, I put that point in there. Okay, so y minus -2 is equal to the slope, which is 1/2, times x minus, okay, x minus 3 over here, like this. See, ta-da! So the -2 and 3 I substitute in this. See, I substitute 3 in place of x, I substitute -2 in place of y, and I have the equation of the line. I'm done. You can maybe simplify this. You have y plus 2 is equal to 1/2 times the quantity x minus 3, and you're done. That's the equation of the line. And that's honest to God legitimate, equation of a line. You don't have to change it into any other form. You don't have to change it in the slope-intercept form. You don't have to change it in the standard form unless you were asked to do so. If you were just asked to find the equation of the line that's parallel to this one that goes to that point, this is it. Y plus 2 is equal to 1/2 times the quantity x minus 3, and you're done. Okay, so but if you were asked to find it in standard form, you could do it, right? Because from here you could find b and just substitute it in there, or from here you could put it in the standard form. So let's just do it for the sake of exercise, even though we're working with fractions, and that might cause you a certain degree of anxiety, but we can handle it. Don't worry, I got it. I'm here. So y plus 2 is equal to 1/2 the quantity x minus 3. I'm going to change this, manipulate this so that it looks to be in the standard form. Okay, so I distribute this. So y plus 2 is equal to 1/2 x minus the 1/2 times -3 is simply 3 over 2, like this. And then to put it in the standard form, I bring this over here, or I can bring the y over here. Okay, so that's what I'm going to do. Actually, I'm going to try to keep this positive. So I'm going to subtract y from both sides. So like this, okay? Because see, in the standard form, x and y are buddies. They're together. So somehow you have to get them together. So in this case, I'm going to subtract y from both sides, and I'm going to get 1/2 x. And if you subtract y from both sides, like this, okay, maybe I'm going too fast for you, so I'm going to do it slowly. 2 is equal to 1/2 x. Subtract y, you get minus y, and still have minus 3 over 2. So I've subtracted y from both sides. And then I'm going to add 3 over 2 to both sides, like this. Okay, and then when you do that, you get this. Okay, let me go down here, probably a little bit over here. So so I added 3 over 2 to both sides. So 2 plus 3 over 2 is 1.5. You get $2, and somebody gives you another $1.50. You get $3.50. Okay, so that's 3.5. It's like this. So that's 3 times 2 is 6, plus 1 is 7 over 2. Okay, so don't confuse yourself with these fractions when they're easy fractions like this. It's like $2 plus 3 over 2 is 1.5, like this, right? So you got $2 plus $1.50, you get $3.50, right? So $2 plus $1.50 is $3.50, and you can. This is a compound fraction, and you can change it. 3 times 2 is 6, plus 1 is 7 over 2, like this. Or you can do it the long way. You can find the common denominator, everything. Anyway, so when you add this, you get this. And here you have 1/2 x minus y, and that's the standard form. That's a legitimate standard form. So if you wanted to put it this way, 1/2 x minus y is equal to 7 over 2. Now, if you didn't like fractions, you can multiply the whole thing by 2 and make it nice and easy. But nobody said that the coefficient of x had to be a non-fraction, whatever. So this is in the standard form, and that's perfectly all right with me. So that's how you would do that. So now we found the equation of lines that are parallel. Okay? Okay. Now let's see, I tell you, I have this line, y equals 1/2 x plus 1. That's an easy, nice line. And I want a line that is not parallel, but it is perpendicular to this line. It's perpendicular to this line, and it goes through, let's say, this point right there. I like that point right there. So that point is x is 1 and y is 3. I want a line that is not parallel but perpendicular to that one and goes through that point right there. So something like this, okay? It's like, I'm trying to make it approximately like that. So, you know, okay, I didn't get it perfectly. So here's a line that is perpendicular to that one, and it goes through that point. I try to draw it the best I can over here, right? So it goes to that point, 1, 3. Well, how do I go about doing that? Well, looking at a diagram here, very helpful little diagram that I hope you appreciate the value of now. So there's two ways of finding equations of a line. And let's say in this case, I'm telling you, I want this in the slope-intercept form. I'm telling you, we want to do it in this form. Okay, fine. So to do that, 2 steps, right? Really, 2 steps. I would need to know the slope of this line, the yellow line. So I would need, first thing is I have to find the slope. So finding the slope. Now, what's the slope of this line? If you recall, parallel lines have the same slope, okay? And perpendicular line have negative reciprocal slope. That's negative reciprocal of the slope, which means that if this line slope is 1/2, the slope of the perpendicular line would be the flip of it and a negative of it, okay? So the negative reciprocal of 3/2, the negative reciprocal, first I flip that, that would be 2/3, and I change the sign. Negative becomes positive. So that's the negative reciprocal. I'll give you another example. The negative reciprocal of 1/5 is, first I flip it, that's 5/1, right? And then first I flip it, and then I change the sign. So negative reciprocal, okay? So perpendicular lines that have slopes that are negative reciprocal, and parallel lines have slopes that are the same. So that is a bit of information that you kind of have to know. Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocal. Let's flip of it, and then you change the sign. So the slope of this yellow line I made is going to be negative reciprocal of this, which is I flip the 1/2, and that would be 2/1, and I change the sign. Don't forget to change the sign. So negative reciprocal. That's easy peasy. The second step is I have to find the y-intercept. Okay, so if you want to do it in this way, so finding the y-intercept. So here, first step was find m, find the slope, and second step was how do I do that? Well, I write my working equation. So far I know the slope is -2. That's a -2 x plus b. Now I don't know what b is, but that's what I'm trying to find. Well, to find b, you need a point that's on the line where you can substitute for x and y and then solve for b, right? Do I know a point or not? Of course I know the point. It's given to me right here. So, okay, I plug that in. So I plug that in place of x and y. So I have x is 1, y is 3. Don't make this mistake. 1 is equal to -2 times 3 plus b. This is a common mistake students make. I don't know why they do that. They substitute 1 for y, where the y is actually 3, and they substitute 3 for x, where x is actually 1, because 1 comes before y. I don't know why. It's just put the, it's kind of like saying, it's calling somebody whose name is Joe Brown, or somebody whose name is Brown, calling them Joe or James or something. No, you just call them by the proper name. Y is 3, not 1. Alright, anyway, so substitute correctly. There's no point substituting incorrectly, then you get the whole question wrong. Alright, so y is 3. So 3 is equal to -2 times x, which is 1 plus b. That's pretty easy. So that's 3 is equal to -2 plus b. And then I add 2 to both sides like this to solve for b. So b is equal to 5. I hope I did that correctly. So now I have it. I have both the slope and the y-intercept, and I could write that y is equal to mx minus 2x plus b, which is 5, and I'm done. So that's it. This is in the slope-intercept form. Now, if you want it in standard form, I just bring the x on this side, so then add positive 2x to both sides to get rid of the 2x. So add 2x to both sides like this. And if I wanted to put that in standard form, I bring that here. So I have 2x plus y is equal to 5. There it is. Okay. Now, if I wanted to do it in this way, if I wanted to find it in the slope-intercept form, the process is very similar. First step is, of course, finding the slope. The slope would be negative reciprocal, which is -2. The second step is easy here because you just enjoy, because we're already given a point here, see? So then you just put that point in there. Y minus the y is equal to the slope, which is -2 times x minus 1, and you're done. So you can see how the point slope form is so useful in finding equations of line if you're given a point, etc. Okay? So today we learned something very, very important and really cool, I think, in a way. So finding equations of lines that are parallel to a given line and or perpendicular to a given line. The idea being, first you have to know that parallel lines have the same slope but different y-intercepts, and perpendicular lines have slopes that are negative reciprocals. Okay, and the thought process is the same. To find equations of a line, you have to think in terms of finding in the slope-intercept form or the point-slope form, and from there you can convert it into the standard form if you need to. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.